So now for this next one, we have f of x equals 81x to the fourth minus 16. So now we don't have a trinomial anymore. So if you have two terms, it could be a difference of squares, or we could have a sum or difference of cubes. So this one is obviously squares, because 81 and 16 are both perfect squares. And with a variable, as long as the exponent is even, it's a perfect square. Okay, so to factor a difference of squares, that's where you have something squared minus something else squared, and it has to be minus. You can't do a sum of squares. So to factor that, you're going to take the square root of each of them, and then one is going to be minus, one is going to be plus. Okay, so this is how you factor a difference of squares. So on this one, to completely factor, I'm going to take the square root of 81x to the fourth. So that'll be 9x squared. To square root a variable, you just divide the exponent by 2. Square root of 16 is 4. So that'll be my first factor. And then my second factor will just be plus. So the reason it has to be minus, if you were to FOIL this out, it's got to give us this answer. So when you do the outside, that would give us positive 36x squared. The inside is going to give us negative 36x squared. They're going to zero each other out. Okay. If this was a plus, you couldn't make both of these plus because that outside and inside term, when you FOIL it out, they're not going to zero out. Now, once you've done the difference of squares, remember, we're trying to factor all the way down to something linear if we can. So I need to look to see if I can further factor either one of these two. Okay. Well, this one right here, this is still a difference of squares because 9 and 4 are both perfect squares. This one right here is a sum of squares, so I cannot factor this one any further. But I can take that first binomial one step farther and do 3x minus 2, so I just square root of each of these, and 3x plus 2. And then I'm going to tack on that 9x squared plus 4, which I couldn't factor any further. So make sure you don't drop this when you're factoring this part. Okay, your final answer needs to be, if you were to FOIL all of this out, it's going to get us back to this answer. So there's our completely factored form. Now for our zeros, we're going to get add 2, divide by 3 from this one. So 2/3. Here it would be subtract 2, divide by 3, so a negative 2/3. So I'm just going to write that one as plus and minus 2/3. So that's the 2 zeros from this one. This one I'm just going to solve using roots. Okay, if there's just an x squared, I usually think solving it by square roots is faster than going through the quadratic formula. So I subtracted 4 divided by 9. Then I would take the square root of everything. So again, that's going to be a plus and minus. Square root of negative 4. Square root of 4 is 2, but since there's a negative, we got to include an I. And then square root of 9 is 3. So that'll be our 1, 2, 3, 4 zeros from this x to the fourth polynomial. Now let's look at another type of binomial example. So this time we have f of x equals 8x to the fourth plus x. So this one's a little different. First it has a GCF. So if there's a GCF, you always want to take that out first. So I can factor out the x. Okay. And I for sure know this isn't a difference of squares because 1, it's not subtraction, and 2, 8 is not a perfect square. Okay, but 8 and 1 are both differences, are both perfect cubes. So what we have here is a sum of cubes. So when it's cubes, you can do sum and difference of cubes. So to factor a sum or difference of cubes, you're going to have something cubed, and when it comes to a variable, it's a perfect cube if its exponent is divisible by 3. So you have something cubed plus or minus something else cubed. So to factor it, what you're going to have first is a binomial. So you're just going to cube root each of these. Okay? And whatever this sign is, you're going to keep it the same. So plus stays plus, minus would stay minus. Okay, now the second part is a little more complicated. Okay, so this part's going to be a trinomial. So what you do is you work from this binomial here. So you take this term, you square it, whatever this sign is, you change it. So plus turns into minus, minus turns into plus, and then you multiply these two numbers together, and then your last term is always going to be this squared. So anytime you square something, it'll always end up being positive. Okay, and this is how you factor a sum of cubes. Now this trinomial right here, that never factors. That'll always be prime. So what you get here should always be prime. So if you end up with a trinomial that you're able to factor here, that means you factored your sum or difference of cubes wrong. So now I'm going to continue to factor this one. So I'm going to leave the x. Okay, so to get the binomial for the cubes, you cube root this. So that'll be 2x. You keep the sign the same. Cube root 1, which is still just 1. Then for the trinomial, I'm going to square this. So 2x squared is 4x squared. I'm going to change that sign and multiply these together. So that's just 2x. And then I'm going to square that. Okay, so now remember, this will never factor. Okay, so this is the completely factored form. Then to get my zeros, okay, that's just all the x values that are going to make the function equal to 0. So from this one, I would just get a 0. This one, I'm going to get a negative 1/2. I know that this one doesn't factor, so I'm going to have to do the quadratic formula here. So the opposite of b is going to be 2, plus or minus the square root, negative 2 squared, that's going to be 4, minus 4ac, so that's 4 times 1, all over 2a, a is 8. Okay. So this is 4 minus 16, so this little part right here is going to end up being negative 12. Okay, so I need to simplify this first. Anytime there's a negative, whether or not you can simplify this, you always need to put an I outside the radical. So even if this had been negative 11, I would still need to write it as I root 11. Okay, but we can simplify 12. 12 is 4 times 3, so square root of 4 is 2, so that's going to be a 2i on the outside, and then that 3 from the 4 times 3 is left. Now that I want to look at these three parts, I can reduce them. I can divide them all by 2. So when I reduce that, that's going to give me 1 plus or minus 1i. So I root 3 all over 4. Okay, and that'll be my 4 zeros. 1, 2, the 1 plus is 1, the 1 minus is the last one. Now let's look at one last example. This time we have 4 terms. We have f of x equals x to the 5th minus 4x cubed minus 8x squared plus 32. So anytime it's 4 terms, if it's going to be able to factor, it'll be by grouping. Okay. So you want to group the first 2 and the last 2, and you typically want it in degree order. Okay. With these first 2, the common factor is an x cubed. So I'm going to GCF out the x cubed. That leaves me with an x squared minus 4. Okay. So then I'm going to take the GCF out of this one, and I want what's left over, the binomial that's left over, to match this one. Okay, that's how you know grouping will work, is if what you get here matches the binomial in the second part. So here I'm going to take out a negative 8, because I know I want this sign to be a minus. That's why I'm factoring out the negative. And so that'll leave me with an x squared here minus 4. Okay. So now both parts have an x squared minus 4. So now this is considered one term right here. This is considered one term. This is like the first group, this is the second group. So both groups have an x squared minus 4. So that's the new GCF. So I'm factoring this out, and what I'm left with is an x cubed minus 8. Okay. Now these two binomials, we can factor these more. This first one is a difference of squares. So this is going to factor into x minus 2 x plus 2, so I was able to factor this one into completely linear factors. This second one is a difference of cubes. So again, I'm going to cube root each part. Okay. Then I'm going to work with this to get the trinomial. So I'm going to square that, change this sign, multiply these two together, so that'll be plus 2x, and then I'm going to square this, so that'll be positive 4. Okay. And we know this never factors. So this is the completely factored form, okay, but I've got a repeating factor. Okay. So I am going to rewrite it as x minus 2 squared because I want to remember that this is a double root. Okay. And eventually when we get to graphing these, this is going to remind me how to graph it. Usually if I don't write it as squared, I forget that it's a double root. So there's all of our factors. And then our zeros. Okay, we're going to have 5 total zeros. So we have x minus 2, but it's squared. So that means it's a double root. So I'm going to list it twice. Okay. If you don't want to list it twice, you can just write 2 and then next to it indicate that it's a double root. I just think it's quicker to list it twice. Okay, so I get a double root of 2 here. Negative 2 here, so that's 3 zeros. My last 2 are going to come from this one. Okay, so I'm going to have to do quadratic formula here. So that'll be negative 2 plus or minus 2 squared is 4 minus 4 times, that's 1 times 4, all over 2a, which is 2. Okay. So I know this is negative 12, 4 minus 16. Okay, and we just simplified negative 12 in the problem before. So that's going to be 2i root 3 over 2. Sorry. 2a is just 2. I think I put the 8 from the last problem. Okay, and then I can reduce each of these by 2. So that'll be negative 1 plus or minus I root 3. And that is all 5 of your zeros on this one.